Good morning. I'm Andy Lindeman. You can follow me online in various places at a Lindeman. I work for Big Nerd Ranch, and I really enjoy working there. Big Nerd Ranch writes high-quality books. We also provide training and do consulting. I'm also a maintainer of Spec, a Ruby testing framework you might have heard of. I'm also writing a book called Upgrading to Rails 4, so check that out if you're interested in Rails 4. But this morning, we're going to be talking about building a mocking library, or building a mock object library. This is a hands-on coding talk, so make sure you're strapped into your seats, and I think you'll really enjoy it. So mocking. Mocking libraries are a tool that many of us use in the Ruby community, but I don't think we always understand how they work. Methods magically appear when you write things like object.stub or object.stubs. Methods magically disappear at the end of tests. The stubs automatically get cleaned up. When you set things like mock expectations, which some other speakers have talked about, like object.shouldReceive or object.expects, depending on your framework, these things magically get verified at the end of tests. But I think it's worth knowing how the tools you use work under the hood and how to build simple replicas of them. And that's what we're going to do this morning. We're going to build a mock object library. And I hope you're surprised at how many tools the Ruby language gives you to build one of these pretty easily. Okay, we're going to take a step back and talk a little bit about what the syntax of the library that we're going to build today looks like. I already decided this syntax, and it's nothing exactly like anything that exists currently. Though, as I'll speak to later, Spec may support this syntax relatively soon. So imagine you have a warehouse test double. A warehouse being an object that knows how to store items, how to know if items are included in this warehouse. Imagine we have a production warehouse code object, but in tests we're going to fake it out and use a test double. Nell hit on test doubles yesterday. If we want to set a stub, just a kind of replay of what warehouse should respond to. If we want to just say, hey, warehouse, act like you're full. Respond to the full question mark method with true. We're going to write some syntax that looks like this. Allow W to receive the full message and return true. So then at any point in the test after that, we can call w.full and get back true. If we want to set a mock expectation, again, in the library we're going to build today, we're going to say something like expect W to receive the remove message with a given item ID. And that says, hey, we better receive w.remove 1, 2, 3, 4. It better be called at some point during the test. That's a mock expectation. Everybody with me? Awesome. Let's talk a little bit about what that syntax compiles to kind of underneath the hood. We have this nice looking DSL here, but we're going to have objects underneath the hood. When you build a DSL like this, it's a good idea to just immediately delegate to some object layer underneath you. It makes it a lot easier to test, and it makes it a lot easier to reason about. Okay, so what does something like allow W return? We're going to call that a stub target in our system. It's going to wrap the W object and allow it to have stubs put on it. So we're going to call this stub target. And you'll see it when we get into code that all we do is just call stubtarget.new when you say allow. This part over here to the right, this fluent interface, this chained interface, is going to build up an object I'm going to call an expectation definition. It builds up information about the method that's about to be stubbed, things like the name and the return value. So I could write code that looks like this and have it have the same effect. And again, this is a good idea when building a DSL, a domain-specific language, that really you can construct the thing underneath it relatively easily. And the DSL is just a nice layer on top of it. Okay, I'm going to have some audience participation in this slide. Let's talk about Ruby's method dispatch. If I have an object called O, and I call 2s on it, how does Ruby know what code to run? How does it find 2s? Anybody?
Class.
What was that?
It starts looking at the current class.
Yeah, it starts looking at the current class, but it could go up to superclasses, right? Ruby calls this the Ancestor Chain, and you can get at it by calling o.class.ancestors. And it returns you a list that's meant to be read from left to right. I got that right, left to right. It's right to left for me. So it starts looking at object and says, hey, object, do you have a 2s method? And in fact, object does. So that's the code that gets dispatched. But what if I sent in a message like the magic ID method, the underscore underscore ID underscore underscore method? That's not on object. It's on basic object. Well, philosophically, what would happen is Ruby would start at the left, say, hey, object, do you have a magic ID method? Nope. Kernel? Nope. Basic object? Yep. And that's the code that would get invoked. Except I left a little detail out. The Singleton class. It's not listed here, but objects in Ruby have Singleton classes because Ruby allows you to define methods that are only on one object. If I write some code that looks like this, o.define singleton method, giving the symbol hello and returning a block hello, bang string, I can call o.hello and get back hello, but no other object in the system has a hello method. Only O. If I construct a new object, it does not have hello. And the method by which this happens is Ruby defines these singleton methods on the singleton class for specific objects, and each object has a different singleton class. When we're going to build our mock object library, we'll be manipulating objects on singleton classes for objects. So that's all I want to talk about before we dive into some code. Y'all ready for this?
Yes.
All right, here's my terminal. It's white, actually, not black. We're going to make our mock object library a gem, and it's going to be called Ancient Mock. The bundle gem command just creates some files that will be useful when building a gem. It's just some scaffolding. So let's cd into the directory and open up Vim, because everyone here uses Vim, so everyone will be familiar with that, right? I was really surprised actually yesterday at how many people were using Vim and Tmux, which is my setup. If you're not familiar with it, I'm not going to do anything too tricky, but that's my editor of choice. Okay, let's look at a file. Let's look at the gem spec to start off with. It's got some details that I would want to fill out if I were actually publishing this gem, but of course I'm not, so I will just leave them blank. But it does have things like development dependencies down at the bottom. And I'm going to add a new development dependency for Minitest. Now you might be asking yourself, why isn't RSpec maintainer using Minitest? And it's mostly because I'm using some syntax that currently conflicts with the way RSpec is built. Because RSpec may eventually support the syntax I showed, I would conflict with expect. So I'm using Minitest. It's a perfectly great testing library. And that's just to make sure I don't run into some weird edge cases. Okay. Let's look at a file in the lib directory that was created for us by the bundle gem command. It's just 5 lines of code here. One of them brings in a version constant. I'm going to change this to require relative so I don't have to deal with as many load path issues in the tests. And then it creates a place for us to put some code, and that's where we'll be putting code. Now I told you I was going to use Minitest and do this in a test-driven development fashion. So I hope you learned something about my workflow when writing test, and we are going to write this test first. So let's open up a file in the test directory. You can see this down here. I'm just opening up test ancient mock test. I need to create the test directory and save the file. Let's write some scaffolding code that we just need to get some stuff running. Let's pull in Minitest Spec, Minitest auto run, so this file just runs as a regular Ruby file. And let's require relative the file from the lib directory called ancient mock that brings in our gems code. If we've hooked up everything correctly, we can write something like describe ancient mock, do, and then this is where we're going to put our tests. This looks really similar to RSpec, but it's Minitest Spec. I have a key sequence in my editor to run tests, and you'll be seeing this quite often, so let's see it work. Running the tests, and there's no tests, but at least we can see that we've hooked up everything correctly. Let's write the first test. It allows an object to receive a message returning a value, we'll say. This is the simple stub case that we saw on the slides. Let's create a warehouse and just make it an object.new. Again, warehouse is just a test stub we're going to use throughout because it's an easy thing that hopefully everyone understands. Warehouses have items and you can manipulate them. Let's write allow warehouse to receive the full question mark message and return true. This is the syntax that we defined in our slides. If this test does what we want it to, we should be able to call warehouse.full, and it must equal true. I was interested in the talk yesterday because I kind of just, without even thinking, kind of separate the given, when, and then portions of my test by white space. So I just kind of do this automatically, but I found it really interesting that it might be a good idea to formalize these things. But basically, given a warehouse, allow it to receive a message, then test that it can actually receive that message. Okay, let's run the tests. And the first thing, it blows up because there's no method called allow. Undefined method allow for this test class. It looks kind of weird, but that's just the mini-test spec dynamically created class. All right, let's fix that. Let's switch back over to the production code file and define a module called test extensions. Test extensions is going to have these methods like allow, and allow takes in some object. And like we said on the slides, it's just going to immediately construct a stub target. What does stub target do? Well, for now, let's just define it to take in an object in its constructor and save it off as an instance variable. Okay, down here at the bottom, let's reopen the mini-test unit test case class and include ancient mock test extensions. So this brings in the test extensions module, which has things like allow, and will eventually have methods like receive and expect. All right, let's run the tests. We're a little bit farther along. Now undefined method receive. So Ruby's trying to evaluate the right side of this expression, this part over here. Let's fix that by switching back over to the production code and defining a new method called receive that takes in a message name like full ? Like we said on the slides, this is going to start constructing an expectation definition. And we'll pass in the message name in the constructor. Let's define expectation definition, have it take in a message name in its constructor, save it off to an instance variable, and we'll actually expose this as an attr reader so that things from the outside can say, hey, expectation definition, what message were you defined with? Let's run the test again. We're a little bit farther. Now and return is undefined. And this is where some neat stuff starts happening. The tests are actually telling me exactly what code I need to write, basically. There's an and return method. It's undefined, and it's undefined on expectation definition. So that's where I need to put it. And return takes in a return value, saves it off as an instance variable. We'll also expose the return value as an attr reader. And importantly, we need to return self from and return. This is pretty standard when you're doing a fluent interface in an object-oriented language. You keep building up an object and return self every time to support chaining on more methods. So because we're writing code that looks like receive and return, and eventually we'll have receive with and return, you return self every time, so the object just keeps getting built up. Okay, let's run the tests. Now there's an undefined method to for stub target. That's the next method we need to write. This is, if we look at the test, what's happening is allow is returning a stub target, and we're trying to invoke the to method on it to make that stub happen. Going back over to the production code, let's scroll up here to stub target and define to. Now to is getting called with one argument, an expectation definition, and we'll just shorten it to be definition as a local variable here. Now what does it need to do? Well, it needs to define a method, right? And to do that, I'll use the syntax I showed in the slides, obj.define Singleton method. The first argument is the method name I want to define. Again, I'm defining a method dynamically here on the Singleton class. So definition.message, that's the message name. And what's the implementation? Well, just the return value. Just give back the return value. If we've hooked up everything correctly, we have our first passing test. We've stubbed a method on an object in about 5 minutes or so and in about 42 lines of code. Except I hope some of you are a little uncomfortable. We've just defined a method on an object and left it there. Most mock object libraries clean up after themselves, and ours is not. This is best demonstrated by yet another test, right? So let's write another test to demonstrate the problem. It removes stubbed methods after tests finish. Let's create another warehouse object. Let's allow it to receive the same message. This is just the line from above. Let's make up a new method on our ancient mock module called ancientmock.reset that will reset the state back to what it was previously. Most frameworks have a method like this. Our spec calls it reset as well. And the implementation is going to be something like, hey, go back to the state before you started stubbing things on things. So go back to the point before we had a full method. So if we try to invoke full on warehouse, what should happen? Exactly. So we'll use assert raises to say, hey, if we try to call warehouse.full here, it should raise an exception. All right, let's run the tests. Undefined method reset for the module. So that tells us where to put the code. Let's switch over to the production code. We'll put it toward the bottom here, and since it's a module method, I'll use def self.reset. That puts it at the module level. And I'm not sure what to do here. And I'm not sure what to do here because if you look back up at stub target, when we define a stub, we're just defining a singleton method and going on with life. We actually have no registry of methods that were stubbed. We don't even have a list of methods that we stubbed, so it's pretty much impossible to do a reset right now because we don't know which methods our library stubbed and which ones were just there beforehand. We could probably do some crazy Ruby magic to figure this out, but it's not what I'm trying to demonstrate. What we need is some sort of separate class that defines stubs, but also keeps track of what stubs exist. So because I am such a creative namer, I'm going to name a new class called stubber that is initialized with an object that saves it off as an instance variable. And it has a method called stub that also takes in a definition. And we're going to move the code that's currently up here in stub target down into the stubber class. And instead of in stub target doing the definition ourselves, we're going to create a new stubber and delegate down into the stubber class to do the stub. Now, right now, we've done functionally nothing different. The code works exactly the same. And in fact, we can verify this by running the tests again and seeing that the first one still passes. But the second one is still failing, of course. But it's failing for a slightly different reason now because we defined the reset method. We expected that there was a no method error to be raised, but nothing was raised. So we've got a little bit of work to do still. But at least we've gotten a refactoring that didn't break entire portions of the system. OK, so stubber.stub is going to do something a little different. It's actually going to save the list of things that were stubbed in an array called definitions. So it's going to shovel on each definition before it stubs it, so it keeps state around about what methods were stubbed. Definitions is just going to be an empty array initialized in the constructor. OK, this is closer, but we still don't have a list of all the methods that were stubbed because this stubber instance immediately goes out of scope and gets garbage collected. Well, so instead, we're going to create a custom constructor at the class level of stubber that saves the stubber instance in a list. I'm going to name it forObject, and it's going to take in an object, and it is going to construct a stubber for that object, but it's going to save it off in a hash keyed by the object's ID, and it's going to lazily create it and save it for each object. One object, there's a one-to-one between an object and a stubber. This code looks a little weird, but it's actually pretty much straight from our spec. Our spec does something really similar to this. Our spec calls them mock proxies, though, but it stores them in a hash keyed by object ID. Well, we need to define stubbers. Stubbers is just at the class level going to be a lazily initialized hash. Now, instead of constructing a stubber up here with .new, we construct it with forObject. So that does the construction, returns an instance, and also saves it in a list.
This doesn't get garbage collected because the stubber class doesn't go away, as opposed to stubber instances?
Right. Since we're defining stuff at the class level, this is kind of basic with effectively global state, but it's OK for now. I'm not trying to do everything correctly, or else this talk would be 5 hours long. OK, what do we want to do now? we want to have one method to call to just reset everything at once. Let's make up some code that we wish existed at the class level of stubber called self.reset. So we can call reset on stubber, and just everything gets cleaned up. What code would we have to write to make that happen? Well, we'd want to tell each stubber to go reset itself. And we don't have a method to do that yet, but let's just assume that we're going to create one. I do this all the time, just like, I will write a reset method later. So loop through each stubber instance that was saved in that global hash and reset it. And then also clear out the list of stubbers, because the list of stubbers is no longer valid after they reset themselves. OK, I know you're thinking, what does reset do? Let's get there now. At each instance of stubber, we have a list of definitions, a list of stubs. What should reset do? Well, it should go through each of them and remove them. So let's loop through each definition. And unfortunately, there's not any public way that I know of to remove methods from a class. So we're going to have to get a little weird here, but that's OK because we're a mock object library. We're allowed to get dirty. We're going to evaluate a block of code in the context of OBJ's Singleton class. This is effectively just writing code between class statements in Ruby. So any code that gets run here is kind of run in the context of obj.singleton class. And we can write private methods because we don't have to give an explicit receiver anymore, because self in this block is obj.singleton class. So we can just write remove method, definition.message if it was defined, if method defined, definition.message. So remove the method if it was defined. OK, it's been a while since we've run the tests. It's making me a little nervous, so let's run them. And nothing is still happening yet. Well, we're still getting a failure because no exception was raised. We've built up all these reset methods, but we haven't called them in the one reset method that really matters, ancient mock.reset. So let's go down to the end of the file and call stubber.reset here. Stubber.reset, if you'll know, goes through each stubber, resets it, and clears everything out. Running the test, we have 2 passing tests. So we have the stub and the unstub case. All right. Except there's a third case, right? What if the method existed already? What if there were already a full question mark method that was defined elsewhere? We're just removing it, right? So we're killing state that existed already on the objects. Again, this is best recognized as a test. Let me write that. Hopefully it'll make sense. It preserves methods that originally existed. Let's create a warehouse object as usual. Let's define a method on the warehouse singleton class. This is yet another way to define methods on Ruby singleton classes. This defines the full method to return false. So the warehouse is initially false, is initially not full. Full returns false. Let's stub it as true. Let's reset, and we expect it to go back to false. So it was originally full before the stubber got involved, stubbed it as true, reset, should go back to false. Except you guys know what's coming, right? A no method error. Because we just nuked it. We just took it away no matter what existed there before. So let's fix that. Let's go back over to the production code. Let's go down to the def stub method. The def stub method does not care what existed beforehand. It just defines a singleton method. And if there was already a singleton method, it's just gone. So really what we want to do is before defining a singleton method, we want to preserve the method if it already exists. How do we do that? Well, we can ask the singleton class, does a method already exist on you with this name? If obj.singleton class .method defined ? For the name of the method, definition.message. Hey, if you've already got a method defined on you, let's get a method object that represents that code. Ruby doesn't necessarily have first-class functions, but it does have method objects. You can actually ask Ruby for an object representation of your method. And you get at that by saying object.singleton class.instance method definition.message. This returns a method object that looks very similar to a proc or a lambda, except it was created via the implementation of the method. And let's save that off in an array in an instance variable called preserved methods, where preserved methods is initialized in the constructor to be an empty array. So if a method was already on the class that we're about to run over, we preserve it. Now down here in reset, after we've removed the methods, we really want to loop through the ones that were preserved and redefine them as their old implementation. So let's do that. Preserved methods.each, do method. A small nuance here, we really want to restore them in reverse order. Ordinarily, I would write a test for this, and it's a great candidate for a test. But because I want to show you guys so many things, I'm going to skimp on test coverage a little bit here. But otherwise, if you stub something multiple times, the wrong implementation would be restored if we didn't do them in reverse order. Because we're building up the preserved methods list from left to right, we want to restore them from right to left. Okay, so that's what that means. Now, when you have a method object, you can also use an alternative form of define singleton method to just redefine the method with the method object. So while up here, we defined a singleton method with a block of code, down here, we can just redefine the method by passing the method name and the method object itself into define singleton method. So Ruby's instance method that gives back a method object pairs really well with define method and define singleton method, who can also take a method object to redefine the method with that method object that we originally saved.
Say that again.
Yeah. Not happening. All right, let's run the tests. We have 3 passing tests. We've restored the implementation of the methods properly. So we have stub, unstub, and then unstub where there was an original method that we need to keep around. All right, so in 15 minutes we've gotten a pretty sweet mocking library, or at least a stubbing library. We don't have mocks yet though, right? Mocks are expectations, where we expect things to get messages during the test. So let's try that. It expects that a message will be received. Let's have a warehouse. Let me move this toward the top. And let's write, instead of allow, expect. Expect warehouse to receive, we'll say something like the empty method. Maybe the empty method says, hey, warehouse, clear out all your inventory. So we're expecting that in the course of this test, warehouse.empty had better be called. But we're not going to call it. So when we call ancientmock.reset, what should happen? An error. We're going to make up an error name, ancientmock expectation not satisfied. So calling reset here, because we did not call warehouse.empty was not called, then an error will be raised by the reset method when it loops through each expectation and verifies that it actually got the message that we expected. All right, let's run the test. The first thing that's wrong is there's no method called expect. We haven't added it to our test extensions. So let's do that. Flipping back to the production code, the test extensions is toward the bottom here. Let's add a new method called expect that takes in an object. But instead of a stub target, let's call it an expectation target because it's the target of a mock expectation. But it's really, really similar to stub target. So similar, in fact, that I feel pretty comfortable making expectation target a subclass of stub target. Because mock expectations in our library are still stubs. The method implementation still gets stubbed out, but also we verify it. So we inherit stub target's constructor and also the to method, but we want to override it to call into the superclasses implementation of TO, which does this, but also to add the definition to a list of expectations that gets verified. So this is a specialized form of a stub. It's a stub that gets added to a list of expectations to later be verified. Now, expectations doesn't exist, so let's create that. Go to the bottom of the file here and say def expectations is just a lazily initialized array. And it's a list we can use to verify those stubs that are also mocks that need to be verified. Now let's verify we haven't broken anything. We haven't, but our test did get a little farther. now it's an uninitialized constant expectation not satisfied. Well, that's easy enough to fix. Let's go to the top of the file and define expectation not satisfied is a new class that inherits from standard error. It's just an exception. It's a runtime error. All right, run the test again. Isn't it great when you have fast tests? You can just keep running things and it tells you where to put things. All right, now we actually get the failure we're looking for. Expectation not satisfied was expected to be raised, but nothing was raised. So the block of code reset is not raising an error even when our mock was not satisfied. And it kind of makes sense, right? We haven't written any new code in self.reset down here. It's just resetting stubs. It's not verifying expectations. So let's fix that. I'm thinking that it makes sense to have some sort of verify method on each definition that verifies that it was called. So let's just loop through each expectation and call something like verify on it. Now, we haven't written verify, but we will soon. And we're thinking, hey, verify will probably raise an exception if an expectation was not verified. So we need to make sure that even if an exception is raised here, let's still reset all the stubbers, because it would be really annoying if your tests failed due to mock expectation errors and then also stubs just happened to stick around. You would get some weird non-isolated tests. So let's ensure that everything gets reset. On top of that, we actually want to clear out the list of expectations as well, so that we don't get weird feedback between tests. So even if one of the expectations fails, we still clear ourselves out and go back to normal. Okay, let's run the tests. And we've broken it in a new and interesting way. No method verify for expectation definition. We tried to call a method that didn't yet exist on expectation definition. All right, that's easy enough to fix. Let's go to expectation definition and write a verify method. Can anyone think of a good implementation for verify? I can. Let's just raise an exception. Did anyone note that I can make the test pass with that? So I know there's something else here. We intuitively know there's something else, right? But since I've been running the test constantly, I can just write small bits of code and actually see that there's a gap in coverage here because all my tests pass, but that's clearly not right. So let's fix that by writing a new and more interesting test. But I'm going to leave the production code like that because it's clearly a gap in coverage. Okay, the new and interesting test is it does not raise an error if expectations are satisfied. Let's create the warehouse. Let's expect that it receives a message, empty, and then let's call it. And then calling ancientMock.reset should not raise any errors. So we can just write it out in the test, and if it raises an exception, the test will fail. Running the test, they do in fact fail because an ancientMock expectation not satisfied error was raised. All right, let's go back to the implementation. Really, what I'm intuitively thinking here is something like if invocation count is not equal to 1, maybe. Most mocking object libraries allow you to customize the number of times you expect to receive a message, but we're just going to hard code it as 1 for now. That'll be ancientMock 2.0. But and then where invocation count starts out as 0 in the constructor. But we don't have any way to increment invocation count. And in fact, if we look at the place where we define the method down here on line 52, all we do is just cough up the return value. We don't give definition an opportunity to increment that invocation count. So I'm going to change definition to, instead of just coughing up the return value, I'm going to change it into a callable object. It's pretty standard practice in Ruby if you want an object to act like a callable piece of code, like a proc or a lambda, to just give it a call method. Definition doesn't yet have a call method, so let's add a call method. Call is going to look something like still cough up the return value at the end, but also increment invocation count. So this gives definition an opportunity to increase its own invocation count while still returning its return value. All right, let's run the tests, and we have 5 passing tests. So we've got stubs and mocks, basic ones anyway. But we don't have the ability to pass arguments to stubs. We don't have any way to say that a method should receive arguments or receive certain arguments. So let's write a test for that. It allows allows objects to receive messages with arguments. Let's create a warehouse. And this is going to be a really interesting test, actually. We're going to allow the warehouse, we're back to stubs for now, allow the warehouse to receive a message called include ? Which tests if the warehouse includes a given item by its ID. So we're going to stub out the warehouse to say the warehouse does include an item with ID 1, 2, 3, 4, but it does not include an item with ID 9876. So that one will return false. So include 1, 2, 3, 4, true. Include 9876, false. So if we call warehouse.include with 1, 2, 3, 4, it should equal true. If we include on 9876, that should be false. Running the test, the first problem is that we've made up this with method, but it doesn't exist. And it doesn't exist on expectation definition. Let's define it there. We're already in expectation definition here, so we can add a new method, with, that takes in a list of arguments, and we're going to use the splat operator to make the argument list an array. Let's just save them off as an instance variable for now. And again, we got to return self to make the chaining work. Running the test again. The next error is an argument error. Wrong number of arguments, 1 for 0. The quintessential, very confusing Ruby error message that basically means the method was invoked with 1 argument, but Ruby only had its arity at 0. It only expected it to have 0 arguments. And that happened on line 52. So let's go to line 52. That's where we define our singleton method, of course. When you use define method with a block, the method is defined with the same number of arguments as the block, and the block takes 0 arguments. So let's change that, because now we have methods that take in arguments. Let's have the block take in a splat arguments as well. Running the test again, we now get the failure. And failure is good. Failure is better than error. It expected true but got false on line 61 of the tests. So let's switch back over to the test and look at this. This is where we try to call warehouse.include 1, 2, 3, 4 and expect it to be true, except it's false. We can kind of intuit that what's happening is we're not doing any matching on the argument list, right? So just the last stub is winning, no matter what the arguments are. And the last stub says return false. So we could actually invoke include with any arguments, and it would always be false because that's just the last one. Because when we call stub, you remember, we just define the singleton method to invoke the last definition that we got. So this clearly needs to change. It needs to be more of like search for the right definition. How do we search for the right definition? Well, let's loop through the list of definitions. We also have to do this in reverse order just to make sure that we get the last stub. If they're stubbed for the exact same argument list, the last one should win. Again, this should be covered by tests, but I want to show you so many things that I don't have time for it. So let's loop through them in reverse order and detect the one that matches. I don't exactly know how to match a definition yet, so I'm just going to make up a method that I will make exist later called matches ? For each definition. And I'll pass in the definition name, the message name, and the list of arguments that were actually invoked for this specific definition call. And once we find the right one, once we detect the right one, actually detect is the same as find in Ruby. I'll use find because it's a little more clear. We can just call it. So reverse through the definitions, find the right one, call it. This should work, right? Oh my goodness, what? We've broken all of the tests, or at least many of them. Undefined method reverse for nil class. Let's look at this again. Definitions is clearly defined, right? Except it's not. In a singleton method definition like this, in a dynamic method definition, self is changed, and instance variables are looked up on self. So self here is actually obj, the object. It's self in here is not the same as self out here. And it's pretty confusing, but it actually, it makes sense, right? Like self should be the receiver of the calls. So this block is a closure. It can take on its environment, but not instance variables. One easy fix is to just use a local variable and define a local variable outside the block to be the instance variable. This needs to be definitions. So now this block can access the local variable. All right, running the tests. The next thing is that there's undefined method matches question mark because we haven't defined that for expectation definition. Expectation definitions don't know how to match themselves yet. So let's fix that. What does it mean to match as an expectation definition given a message and an argument list? Well, the message should match the message name it was defined with, and we'll either match if we weren't defined with any arguments at all, if arguments is just nil, or the list of arguments matches the list of arguments that were passed in. This looks a lot like I'm defining some sort of equality operator here, but of course equal equal can't really take multiple arguments, at least not, and have it look cleanly. So, and matches also is a stronger name, so I like it better. Okay, let's run the test, and we have 6 passing tests. We have mocks and stubs with arguments in the right order. So I'm pretty psyched. So our library is pretty rockin'. There are some caveats, though, that I do want to address, because I'm sure there's some advanced Rubyists out there that are like, what's going on? If you call with, for example, and pass arguments that were not expected at all, you'll get something like a no method error because the detect will return nil, and then you'll try to call on nil. Our spec, for example, just raises a separate error that says, hey, you called this stub in a way that wasn't, we don't know how to fix that. So that wouldn't be hard to add. You could add some sort of like null callable thing that detect returned by default, and then that gets called and just invokes an error. But I'll leave that to you guys. Define Singleton method and Singleton class are object methods. So our object library would kind of blow up if you tried to stub something on basic object. This is not incredibly difficult to fix, but it makes the code a lot uglier because you have to use kind of more syntactic Ruby method or Ruby syntax to get at things like the Singleton class. So it just makes things look a little uglier, so I didn't go down that road. The method defined question mark method returns false on private methods, as it probably should, but that also means that if you try to stub a private method, why are you trying to stub a private method? But if you try to do this, people do this, we would not restore it correctly. So I'll leave that up to astute readers to figure out. And then of course we would want to integrate reset automatically probably at the end of test. That's not that hard to do in both Minitest and RSpec. In Minitest you hook into teardown. We define a module that defined teardown. Make sure to call super if you do that. And then in RSpec, you would use an after hook. Our library is Ruby 193 and above only, as far as I can tell. It's a really big pain in the butt to maintain a mock object library on something before that. There's just weird behavior and things, so I didn't even try to go down that road. But even given these things, I think our library is pretty cool, and it's pretty cool that we were able to build it in Ruby in about 30 minutes. It's very likely that allow and expect will make their way into RSpec to be kind of a new DSL for doing RSpec mocks, and so look out for that. Follow the issue on GitHub if you're interested. I will push this to GitHub soon. Please don't use it. But if you do want to hack on it to understand mocking more, if you want to write some additional tests and try to figure out how to make ancient mock do the right thing for you, feel free. And there's a link to the slides. I'll also tweet them shortly via my Twitter account, Lindeman. Thank you so much. I hope you learned some things, and I had a great time.